Hello, I'm Bill Serban, Director of the Center for Advancing Teaching and Learning at the University of Wisconsin-La Crosse. This presentation is part one of a two-part series that examines how and why students experience cognitive overload that results in poor learning. It is based on the idea that our ability to process new information is surprisingly limited, which makes new learning potentially difficult and slow-going. In part two, I will explore ways that teachers can manage and reduce the cognitive load associated with their lectures, assignments, and class activities to help students learn more effectively. We expect students to take in and think about many new concepts, procedures, facts, and ideas in a short period of time. This leads to a common problem. Students become overwhelmed by too much new information. For example, in a lecture, the instructor delves into a new topic, and in a few minutes, students are struggling to keep up with the new concepts. Or during a class discussion, students keep jumping from topic to topic, they lose the thread of the discussion, and have only a jumble of ideas in their heads. Why do students become overwhelmed? Is it because the instructor goes through the material too quickly? Does lack of organization make it difficult to keep track of the ideas? What about the complexity of the task or topic? When a new idea is complex, we often have to slow down and think carefully and go back over the material. Other times, when we're talking about a familiar topic, a discussion can be very disorganized, but can still be understood. What's going on? How can we understand this idea of overload? And what can educators do to reduce it so that students learn more effectively? To understand why we become overloaded by new information, we need to examine two key ideas: working memory and cognitive load. Let's start with working memory. Working memory is the part of our memory system that enables us to hold onto a limited amount of new information for a short period of time. Think of working memory as the mental space where we do our conscious thinking. Whenever we take in new information, mull it over, and think about it, that processing or thinking takes place in our working memory. Unfortunately, working memory has a very limited capacity. We can only deal with a few pieces of information at one time. So, if we're inundated with a lot of new information, there is a good chance we simply can't process it. We are not able to keep it active in working memory, and we lose it. Humans are capable of retaining huge amounts of information for long periods of time in long-term memory. However, we need to actively process new information in working memory in order to get it into long-term memory. Unfortunately, we can process only a limited amount of new information at any given time. Working memory, then, is a bottleneck in learning and helps explain why we are overloaded so easily. To get a better idea of how learning breaks down in working memory, we need to turn to the concept of cognitive load. Cognitive load is the amount of mental resources needed to accomplish a task. Any thinking involves various types of mental processing. Familiar tasks, or simple tasks, do not require much cognitive effort. The load is relatively light. But learning new, more complex information entails more mental effort, more cognitive load. We experience cognitive overload when the demands of a task exceed our working memory capacity. We get bogged down, have difficulty processing the information, and learn less. To illustrate, if I asked you to multiply one-digit numbers, you could probably do this easily in your head. The cognitive load would be relatively light. And if I asked you to multiply three-digit numbers, you could probably do this easily if you could work out the answers on a piece of paper. Again, no major problem with cognitive load. But what if you had to do the calculations mentally, without access to paper and pencil? It is quite difficult to keep track of the rows and columns in your head. When the cognitive load of the task exceeds our working memory capacity, we start to falter, make errors, get lost in the procedure, and we may give up. Even a relatively simple procedure like multiplication can exceed our working memory capacity. This example illustrates that humans are endowed with a puny working memory. This limitation makes every learning situation potentially difficult. As we will see, there are ways that teachers and students can manage cognitive load to support more effective learning. But to manage load more effectively, we need to better understand the nature of cognitive load and how it works. Researchers have shown that in any learning situation, there are three sources of cognitive load. In the remainder of this presentation, I will describe each source and the type of cognitive processing associated with it. Intrinsic load is the effort involved in simply trying to do a task or learn something new. It is basic mental processing we need to attend to and initially think about a task or material. For example, to multiply two fractions, you need to start thinking about what the actual fractions are, what the arithmetic procedures are, the sequence of steps, and so forth, so that you can start to work out the answer. This is a kind of basic processing intrinsic to doing multiplication. Extraneous load, on the other hand, is effort involved in processing irrelevant information. It consists of mental processing we do that is irrelevant to the task. Let's say the teacher is teaching students how to multiply two fractions, but is disorganized and interjects irrelevant information into the lesson. The instructor has added extraneous load to the situation, making the task more difficult. Students can also contribute to their own overload. By not attending to the task or by trying to do another task at the same time, students increase extraneous load and the difficulty of learning the task at hand. Third, germane load is effort involved in trying to understand and make sense of the material. It is deeper processing, such as integrating new information with prior knowledge, that is likely to result in better understanding. This idea of deeper processing may be unfamiliar. Think of it as the kind of effort that goes into making sense out of new information and not simply trying to remember it. As teachers, we want students to engage in this type of processing, but it does make learning more complex. For example, if I am learning how to multiply fractions, I could simply follow the rules and carry out the procedure in a rote fashion. Multiply the numerators, multiply the denominators, and then reduce the fraction if possible. In other words, I could learn to multiply fractions with minimal understanding of what I was doing mathematically. But if I was thinking about it mathematically and trying to understand it, I could realize, for example, that multiplying fractions looks different than multiplying whole numbers. When I multiply two whole numbers together, 2 times 2, the product, 4, is a larger number than the whole numbers. However, when I multiply fractions, I get a product that is smaller than the two fractions. This might lead me to think about how multiplying 1/2 by 1/2 is really like taking 1/2 of 1/2, which results in 1/4. Okay, the point is that germane processing involves more effortful and complex thinking about the meaning of the material. To summarize briefly, our working memory has limited capacity, which means that we can only think about a few pieces of information at one time. In any learning situation, there are three sources of cognitive load making demands on our working memory. Intrinsic load is the processing we do to attend to and engage in basic learning of the material. Extraneous load is the extra processing we have to do because of irrelevant information or divided attention. Germane load involves deeper cognitive processing needed to understand the subject matter. It makes tasks more difficult, but the payoff is greater because students tend to develop deeper understanding of the subject. Overload occurs when the cognitive load in a learning situation exceeds our working memory capacity. In part 2 of this series, we will examine how teachers can manage and reduce the cognitive load associated with their lectures, assignments, and activities.